Welcome to Beauties and Beasties, the independent pest podcast for the UK.
Hello. How you doing?
Yeah, I'm okay, thank you. And you?
I'm doing good. I've had a busy week. Lots of driving for me, but also lots of fun as well. Helping
Where have you been going?
B. Pardon?
Where have you been?
Been up to Scotland.
Scotland?
I apologise. I didn't mean to lapse into a pseudo-Scottish accent then. That was wildly inappropriate of me. I've just been up to Scotland.
Wasn't good.
To help deliver some lectures for Lawrence. So actually getting back in front of people again and training, which was, as we all know, one of my big passions is to be, up on stage, talking to people, training, teaching, educating. So yeah, it was just a little bit of a return to that, and hopefully more of that. More of you'll be able to see more of me on the circuits and the road shows as we go along, because I forgot how much I just enjoy teaching and training and getting involved at the people's very first steps into the industry. It's very rewarding. It can be very challenging, but it can be very rewarding.
Tell me about that.
Yeah.
I'll have to tell everybody why I've got. Everybody will have to excuse me.
You're so
worried I'm worried about my bit of cardboard. It's just so I don't get a reflection. It looks a bit tacky, doesn't it? I'm gonna have to get a nice posh. Actually, I need to get a piece of board cut so I can put our luminous sign up. Again.
What you really need to do is you just need to get a bit of clear plastic, and at the very bottom of it, just have a transfer of your face, so it looks as though you're peeking over the glass. That'll work quite well. But no, I ended up. Sorry, say what?
I was going to say, talking about talking in front of everybody. Don't forget, we've got a section at MPTA Pest Tech.
Oh yeah.
You and Sean.
And you, Hugh, you're going to be there as well.
No.
Yes. So for those who are interested, those who are listening right now, Sean, Hugh, and I, all three of us, will be at Pest Tech with our various guises, but one of those guises will be for the Beauties and Beasties podcast, and we're going to do a live podcast from the show. So we're going to take over one of the little lecture halls at the side. We're going to do a live podcast. We're going to probably invite people up on stage. It'll still be recorded. It'll still be sort of like available to view for those who can't make it. But for those that are there, if you want to be involved in the show as it's recorded, going out live, come see us, sit down, bring teas, coffees, even a bevy if you want to. It'll be great to have everyone there. And it should be really good fun. It'll be the first time we've actually done one of these things to a live studio audience, so to speak, as opposed to all.
And just as always, we have absolutely no idea how it's going to work, or how it's going to run, or how we're even going to do it. But we'll get it.
I was going to swerve that particular aspect because we've got several weeks, if not months, before we have to actually do this. Nobody had to know that, Hugh. Nobody had to know that
we have it perfectly, as always, on the ball.
Yes, we are the proverbial swan of podcasts. On the surface, we look regal and dignified and like we know what we're doing, but underneath, my God, are we paddling frantically? But there we go.
So anything new on the horizon for Alex at the moment?
I don't think. Well, other than going to the Pest Awards next week. Not next week, the week after next. That should be good. And I know there are a couple of our listeners actually who have been nominated and will be down there seeing whether or not they've won various awards. So for everyone who's listening who has had a nomination, good luck. I will be there raising a flute at your behest.
I know Stephen's had a nomination. Stephen Seen, hasn't he? He's had a nomination.
Yes, indeed.
Sole Trader. I can't think who else has had them. I know there's a couple others that have had them before, but I know Stephen's up for one of our regular listeners. So best of luck to him.
He'll be doing good. And yes, anyone else in the comments who's been nominated for an award, let us know, because we'll come and say hello, and the rest of it. So that should be good fun. They're always good. It's nice to. I know we've discussed the awards several times, and there's this feeling of paid for awards, or it's a bit of self-flagellation,
and nepotism and everything, isn't it? So it's seen as.
At the end of the day, you have to. It is a wonderful sort of like excuse, if you would, to celebrate our industry, for people to get together, to meet folks that you may not have seen in a long time, and just like have a good night. And of everyone who's there is there because they've done something that either they feel that they are proud of, or that someone else feels that they should be proud of. And as we always say, if you feel as though you should be at the awards, you feel you should have been nominated for something, then not, they put an application in. It feels a bit wanky, but you got to be in it to win it. It's like the lottery.
It's a bit like the on the road days for both the BPCA and the MPTA, isn't it? It's a moment in time where you can say hi to everybody else and have a chat, meet people, do a bit of networking. So yeah, why not? Whatever you think of the event, at least it's a get together, isn't it?
Exactly that. And this year it's all the way up in Manchester, so I've got to figure out the logistics to get up there. I think I'm getting the train, which should be exciting. I'm going to be a public transport wanker for the day.
I didn't know they changed it around. Do they change it to different venues? Do they?
I think so. Otherwise, I'm going up to Manchester. Do you remember the story of Sean, like years ago when we first started this podcast? Yeah. So, ladies and gentlemen, I'm going to regale you with this for the couple of minutes that we've got. When we first started this podcast, Sean had not really. He wasn't sort of like, he hadn't been to many of the trade shows. And he hadn't been to anything else. And he went to go and sort of like book into. I think he was going to go to Pest X. Or Pest Tech, one of the two, but one's in Milton Keynes and one, of course, is in the centre of London. And which one it was that he planned on going to was not the actual one that was on. So he booked all of his hotels and booked all of his transport and booked all of his sort of like logistics around going to the wrong one, and didn't realise this. He didn't realise that a week before or a couple of days before, it was on the day, I believe. And he and a troop of his merry band ended up, marching around. And they only just, I think, managed to find somewhere to sleep local at the 11th hour. Otherwise, they would have been sleeping in cars, like a little pack of wolves. So there we go. Fun and games all around. And yeah, we've got Pest Tech coming up relatively soon. This is going to be your first Pest Tech as a director of the MPTA. How are you feeling about that?
I think it's going to be good. Yeah, I've heard some behind the scenes information. I think it's going to be cracking. I think it's going to be really.
Anything you can share?
I'm not allowed. No, I don't think so. Maybe nearer the time when I get security clearance to give the information out. I think. No, I do think there's going to be some. I think it's going to be quite exciting. So yeah, I hope everybody can go and have a cup of coffee and a chat and have a chin wag and everything.
It's a good venue, and there's places to hide around there as well if you need to go and have a quiet moment. But with that, we're going to start in just a couple of minutes. But Hugh, you've also been telling us you've had the mother of all jobs on. You kind of spoke about it briefly last week when you were setting up. This has been your first week into it. Yeah.
So the bed bug job, yes. I got sent some because as you know, for some reasons I don't go out and actually do anything anymore. I'm just an office boy. But I got sent some photos and some videos of the job of one of the apartments, and yeah, it was pretty bad. In fact, the guys even found them in the freezer, which is in the fridge, in the freezer. They said once they'd finished steam treating everything, it looked like something out of a murder scene because there was so much blood rehydrated on the floor that they had to go and buy a mop and bucket. So yeah, it's going to be quite a challenge. We are really looking forward to getting Apprehend, I think.
Well, yeah, we did the whole purpose of tonight's talk is all around biologicals, and it does seem as though biologicals. It used to be that biologicals were a very niche kind of market. We had the BTI for mosquitoes, and that was about as far as it went as far as professional management gone. But it's grown significantly, and certainly in agriculture, it's become a bigger and more robust field of control, and it's thankfully, mercifully, starting to percolate down into what we do. Because, ladies and gentlemen, you can't see my hands moving like this, but imagine a great big beach ball, and if you were to name that great big beach ball the agricultural sector, and then you were to imagine professional pest management or professional solutions as a golf ball, and you wouldn't probably be far. Actually, yeah, and that's both in terms of scale, revenue, and the resources that are put into them on a global scale. So a lot of what we may get is so Rupert Ferkins is asking, are you realistically going to get Apprehend? Well, as far as I'm aware, actually, Apprehend went through its ECHA listings for the active material, which is a fungus, a little while back. They haven't got a product registration yet, and that could take a little while, because first off you have to register all of your AIs, and then you need to register your products. But Apprehend got bought out recently by Rockwell Labs, so that may help the process along. It may equally hinder the process along. We don't know. So how long is a piece of string? It's certainly not a company that I am privy to the inner machinations of, other than the fact that you tend to keep your ear to the ground on such things, don't we? But
I think it's inevitable. Hopefully
it is. Hopefully it is. But then again, I've just, as I say, spent a week up in Scotland, so I'll give you my favourite Scottish quote, which is, "The best laid plans of mice and men get after day," which basically means it could go well or it could go horribly, horribly wrong. But
so,
as we do you want to introduce our guest while I press the button to bring him in?
Yeah, so we have on to this evening Richard Binks, who's representing Dragonfli tonight. Many of you may have heard of Dragonfli for various reasons, and I shan't steal any thunder. So, Richard, good evening, welcome.
Thank you very much.
And welcome. So, I think we'll start off, if you don't mind. Who are you?
Who am I? Well, I'm, as you said, Hugh and Alex, I'm Richard Binks. I was trying to put some sort of notes together just to sort of set the scene this afternoon, and I thought, well, I'll just sort of go through a bit of biog about myself. I don't normally do this, but I just thought it'd set the scene quite nicely. I've sort of been around for a bit. I'm into my mid-50s now. I know I don't look it, for those people see me on camera. But I've always had an interest in the natural world. And some of my earliest influences, I was trying to think about this really hard, and we have to go back to the 1970s and 80s to people like David Attenborough. People have heard of David Attenborough, and maybe some people have heard of a guy called James Burke, who's a very, very, very clever man and a brilliant science communicator. And when I was younger, these were the sort of guys on the TV that were really, really pushing my buttons and showing me that.
Was that Tomorrow's World?
Tomorrow's World, absolutely. He did independent programs after that as well. But yeah, these were the sort of guys I was watching on TV, particularly David Attenborough with Life on Earth and things like that. So they sort of set the scene for what I wanted to do. And we, as a family, we were always very interested in farming and animals and everything that sort of crept around on the floor, including insects. So that really got me into entomology. I left school at 16, went into an apprenticeship working in an agricultural laboratory, but I soon sort of focused in on the lab on the sort of insect side of agriculture, and particularly nematodes as well, so plant parasitic nematodes. But I realized that I had to go to college as well, so I wasn't, I had to sort of go back to college and learn a bit more. Went through college in Leeds, then ended up in Manchester and studied for an applied sciences degree, and then got to pardon a pun, I got the academic bug. and I didn't want to really leave academia. So I went up to Aberdeen after that and did a postgraduate diploma in crop protection, and ended up then coming all the way back down south to Reading University to do a PhD in tropical entomology and nematology. And that sort of set the scene really for the future of my life, really, which was basically working with growers and farmers around the world, and particularly trying to sort of solve their entomological nematology problems. I did have a stint in the 90s working for ADAS. Some people may know ADAS as an organisation that came out of the Ministry of Agriculture after the Second World War, and has now become a private independent organisation. But I really did cut my teeth in that organisation, working in a plant clinic. And if anybody out there has worked in a plant clinic or in a typical diagnostic lab where they're getting samples in every day of all shapes and sizes, it's a brilliant place to go and learn about everything, because you never know quite what's going to come through the door next. And that's where I got to find out about the eclectic side of farming, particularly, whether it was diseased plant material or smashed up insects in an envelope from Mrs. Smith in Inverurie or whatever. We got that through the door. And I suppose I could see then back in the 90s that the writing was on the wall for things like the chemistry, which farmers have got available to them. But numbers of chemicals were going down, and things like biological control, which we'll talk about a bit more today, was on the up. And I really did start to think about moving my career into biological control. And I suppose bring you right up to date. I've spent the last good number of years now working for a couple of businesses, one of which is Dragonfli, but the other is Koppert, Koppert. It's a Dutch family business that was founded nearly 60 years ago in the Netherlands. And Koppert are the world's largest biological control company. So they basically produce insects, nematodes, pollinators, and other products. And what spun out of that was a company called Dragonfli. And there was a need, particularly in the UK, to set up a subsidiary of Koppert, if you like, using Koppert's products, but aim those products at the home and garden market. So they're sort of the products that come out of Dragonfli that you can buy online are basically sort of smaller versions or smaller pack-sized versions of the commercial products that we use in agriculture and horticulture in the UK and around the world. So Dragonfli has sort of also added other products to their portfolio, some of which we can talk about this evening. But again, I'm in a supporting role in both of those businesses, get involved in a little bit of R&D, a little bit of development, sales as well. But again, it's very, very eclectic sometimes. You never quite know what's going to come through the door, what sort of problems growers and farmers are going to throw at you. But I think, as Alex has said, it's almost bigger than a beach ball. I think, Alex, biological control as a concept's been around for over 100 years, but commercially probably a good 50, 60 years. And it was people like the Koppert family and other businesses that really, really did pioneer the production of predatory mites, parasitic wasps, entomopathic nematodes, etc., at a factory scale, so that we could then package them up, send them out to farmers and growers, and be able to do those guys to practice more holistic ways of actually controlling insects predominantly.
Why do you think that change took place?
Well, there's been several. Yeah, I think obviously we go back to the sort of 1950s, 60s with the sort of the sort of Spring written by Rachel Carson, and the sort of her being able to flag up. Brilliant, very good, on cue. That sort of book really did set the precedence of how nasty some of the chemistry was out in the world. And Alex, did you have a question?
No. Go ahead. I was about to say it's interesting that Silent Spring had such a profound impact on our industry, and yet if you actually go back and have a look at it, a lot of the claims which were, that put such pressure on chemicals such as DDT, for example, was the claims that the increase in DDT was a causal factor in the increase of things like childhood leukemia, which actually was never proven, and actually then went further on to be chronically disproven. But it's interesting to see how books such as this can have such a profound impact, and we see similar things even today. You know, we're seeing the reduction of glue boards based on popular opinion rather than on solid science. And everyone knows the story of Silent Spring, but nobody quite understands the impact. And not to detract from your story, but the removal of things like DDT from the World Health Organization's malaria control program actually is shown to probably have killed more people through a chronic reduction in malaria control, having to revert back to things like deltamethrin, which was already having a burgeoning resistance to it. More people than anyone else on the planet, you know, and a lot of these despots and dictators combined, which is a tragic thing. So we have to be very careful with our causation and correlations when it comes to making decisions about chemicals in the future. I just
Absolutely
say that just in case anyone who makes these decisions may or may not be listening.
Yeah, absolutely.
You know.
I think one of the big drivers was, particularly in the protected industry, was the use of pollinators. So again, if you start throwing lots of chemicals around your greenhouse when you've got lots of nice tomatoes growing in there which need pollinating by bees, then obviously you throw the chemicals around, you're going to kill your bees. So again, that was it. And again, in strawberries, soft fruit, again, we rely very heavily on pollinators to pollinate the crops. So again, there was that sort of movement, particularly in the late 70s and into the 80s, 90s, where growers were seeing reductions in chemicals available to them to kill insects. But then obviously there was an upsurge in the use of biological control. Costs were coming down as well with regards to buying these predators to put into greenhouses. And again, you know, when you're working in confined spaces, I'm sure many of your guys out there will probably realize, you know, it's not nice work at the best of times, you know, putting on lots of protective clothing, etc. on a warm day, particularly in a glass house, is not great. Whereas if you give somebody a bottle of insects and say, put those out into your tomatoes or your poinsettias or whatever, it's a lot more user-friendly. So there was some of that, you know, trying to sort of reduce that, take that operator safety of using chemicals out of the equation and getting people to use biologicals more. And that's where we're seeing now, along with other drivers like reduction in chemicals not being approved for use in the UK and Ireland anymore, because we're our own little island now, aren't we? Then, yeah, it's just a lot more user-friendly way of actually controlling pests.
Is there a microphone on your chair leg or the floor? Why is it making a noise?
On my leg?
Or anything?
No, somebody. Sorry, I took over then. I hope it's
weird comment aside. Yeah, the field of biologicals is one that, as you say, has been well established, but not necessarily well adopted, should I say, into the professional pest management sector as of yet. And there are options. I mean, classically, the one that we all kind of know about and have used has been in vector management, like BTI, so bacterium for destroying soft-bodied larval insects, specifically things like mosquito larvae. But they've already come with drawbacks. So I suppose I'll start this. Let's start this whole conversation around biologicals with what might be the question at the front of everyone's mind. I mean, let's take defender mites, for example. Now, I have over here, you may or may not be able to see, a whole stack of Vivaria where I keep snakes. Sorry, guys, I keep snakes for fun. It's something that I do, it happens. But occasionally, snakes will get mites. And snakes are not very good at chemical treatments. So what you have to do, therefore, is introduce these things called defender mites, which is a predatory mite, into the equation. But with things like that, the defender mite can only exist and thrive and do its job so long as it has food within which to sort of like control. And ultimately, you end up getting to a point where that nature finds a way, as Jeff Goldblum would say, and it always finds an equilibrium and it always finds a balance. And so with that, you very rarely find populations of predators outstripping the environment that they live in order to survive. And the same thing going for parasites with this. So with our biological controls that we have look at, and I'm thinking specifically of the things like the wasps here, how does that work? How do you get a full control? Let's talk clothes moths in someone's house.
Okay, so if we just think about what biological control is, so we're using, insect biological control is using living organisms produced in a factory environment. Again, historically they were produced in a laboratory, but now obviously we've got them at scale, and we're trying to not necessarily eliminate. It's probably going to be really, really difficult to eliminate all your pests in your greenhouse or in your field, but you're trying to sort of regulate those insect populations to get them below. If we think about agriculture and farming, we're trying to get them below a threshold, particularly things like damage to a crop. So we can get them to a level where they're actually manageable and tolerated, if you like, within an environment, and obviously then that will allow us then to reduce or even eliminate the use of chemicals. And there are three main areas of biological control we think about. So you've got classical biological control, which is how it really all started, and that's sort of bringing a natural enemy into a pest's native region, if you like, and where a pest has become invasive. So an example of that would be sort of bringing in parasitic wasps to sort of control an invasive whitefly species, for example. And that classical biological control stuff still goes on today in various parts of the world. But then you've got the bit that I spend most of my days talking to growers about, is augmentated biological control. So that's the grower buying or bringing in a parasitic wasp or an entomopathic nematode in very, very large numbers, and then putting those into an area to inundate and take over the pest population. And there's a lot of science behind that, insofar as numbers of insects that we bring into an area at scale to try and outstrip or take out those insects or predatory mites or those mites, etc. And then there's a third area, which is conservation biological control, which is probably, if there's any gardeners out there, and I'm a real passionate gardener, that's working with nature to try and help nature control or reduce pests in places like the garden or on the farm. So one example of that is planting companion flowering plants. So these flowering plants will attract beneficial insects, things like lacewings and ladybirds, parasitic wasps, etc., hoverflies. And they are coming out. They're out there in nature doing their job every day, and that allows then us to get a balance. So it's bringing in different sort of flowering plants, if you like, into the environment to try and sort of help us control pests. And that is very much a big part of, say, organic farming, and again is starting to see a lot, farmers and growers who don't have the chemicals anymore, but they used to. That's now starting to see a big upsurge, particularly in agriculture and horticulture.
I was about to say, so those of you who know that my secondary offices and my little insect laboratories that I have sit up on a farm out in the middle of Basingstoke, and this farm specializes in low impact farming. And one of the big things that they do is, instead of sort of like heavy plowing the fields, the rest of it, they'll plant cultivator crops, which by their own admission are basically posh weeds, but it's sort of like a collection of a lot of different flowers, and some of them have very deep tap roots. They sort of like penetrate down into the soil and the rest of it. But not only do they have these, and this sort of like helps re-nitrogenate soil, it helps sort of like break up the soil, all of these other things. But what they will do is they'll also leave strips of them active even when the crops are up, specifically for this reason. A, they're bringing in pollinators, but B, they are keeping in insect predators. And it goes so far as to, I believe, that in places like France, for many, many years, they would ship in things like Chinese mantis, which are absolutely sort of like they'll eat their own body weight every day in insects. And if anyone's ever kept a mantis or seen a mantis, it doesn't necessarily have to be an insect smaller than the mantis. These things are voracious, but the one thing that Chinese mantids can't do in the sunny climes of France is survive over winter. So they basically scatter these erythecia out, and you get hundreds of tiny little killing machines running rampant across the fields that never make it over winter. However, there have been some issues. I mean, not to detract from this, but let's talk about Australia for a second. How biological controls can go wrong, because they brought the cane toad in, didn't it, and the mosquito fish, and soon they are planning on releasing a species or variant of herpes into the water to control carp, and I can't see anything going wrong with basically dumping gallons of herpes into waterways. But there are these apocryphal sort of like tales. So what would you say in defense of those, putting the wrong animal in the wrong location? Because it's a fear. What happens, when it goes wrong?
Well, those examples that you're talking about there, Alex, are probably more down the classical biological route. When we look at augmentation and what we're working within businesses like Dragonfli and Copper, is we are working with insects which have to be either under license or don't need a license, and those that don't need a license are obviously native, particularly native species to the United Kingdom, if we talk about United Kingdom, or say Northern Ireland, which is part of GB. So they're covered under different legislation. So they're covered under different legislation to pesticides. So a lot of my guys will say, do they have a MAP number, for example? So like a pesticide, well, no, they don't, because they're covered under different legislation. And there are many countries around the world. New Zealand, you mentioned Australia, but particularly places like New Zealand, where the biological control is almost non-existent, because they've just not allowed non-native species to be released, and we're very highly controlled as an industry as to what we can release and what we can't release. But rest assured, what we are releasing, particularly in a glass house, is going to be safe to use. And the numbers that we're talking about are tiny insofar as the wider landscape. One of my passions really is entomopathic nematodes, and again, Copper as a business is the largest producer of these nematode species in the world. And some species are native to our soils and some aren't. But we'd need if they're not licensed, if they're not native, we would need a license to produce them and then sell them. But the nematodes that we use are so good at doing their job. We've been able to use these not just in horticulture, but now move them out into wider scale agriculture. So a lot of my work over the last 3 or 4 years has been basically looking at developing the use of entomopathic nematodes in field crops at scale. So, being able to spray these out to try and control insects like caterpillars. And I think, Alex, you mentioned earlier on, some of these nematode species do parasitize soft-bodied insects, or soft-bodied insect life stages, predominantly the larvae, and that's really been the big area that we've worked on with a lot of success. Things like pests like wireworm that affects a lot of root crops, some of the fly species like carrot fly, bean seed fly, etc. These are now being regularly used by growers that we're used to using chemicals to control these pests, and the nematodes are, they are native. But one question I get is, are they going to disrupt the biodiversity in the soil or on the plant? And there's been lots of studies, and many of the people listening to this podcast can go back to the academic studies on Google Scholar and things like that and look. And there's been lots of studies as to whether these would take biodiversity out of balance, and the results are just they're pretty conclusive in saying no, because they are native, most of these species that we use, and they're not going to outbalance nature. They just are literally a drop in a swimming pool insofar as the wider picture. But some of, as you said, Alex, some of the classical biological control releases that they've done around the world have caused car crashes. but we're not
multiple times.
Yeah.
And it's good to hear. I mean, I say that not to sort of like poke sticks at biological control, but mostly it is something that we hear of. It's something that, you know, and you're raised on stories of cane toad and lesser known mosquito fish, and even to an extent actually myxomatosis, because that was a form of biological control that was that went the other way. That was so phenomenally effective, it became too effective, and we ended up in the UK having the Specified Pathogens Order in 1998, which encourage people to actually stop and mitigate the spread of things like myxomatosis and VHD. That's just when it gets too good. And I suppose that's what you're saying there, which is when you have a biological control which is too effective, which doesn't find an equilibrium in the environment, then it starts to become problematic.
Yeah.
So let's talk about wasps, because they're probably the ones that are most...
question, I think, from...
from Rupert, yes.
Clothes moths.
So for those listening back, because for those listening on Spotify and they're driving in the morning, Rupert says, not that I get a lot of calls for textile moth, but I always mention about parasitic wasps as an option. Just a small selection of people I've mentioned it to have mostly been horrified at the idea. You think that more people would be attracted to this option in this day and age?
I've actually, I've got to say, the people that I have mentioned it to, and we're just looking at a couple now, they've been like, really? That sounds absolutely fantastic. So I've had sort of the other way. I've had quite a few questions and saying, what happens to them when they finish? Oh, am I going to get loads of wasps flying around around the house? So maybe we ought to start at the beginning. I think
let's start there, and because I think a lot of people who think wasp obviously think naturally Vespula species, genus, or big wasps flying around, but that's not the case, are they? I mean, the parasitic wasps that we're talking about here, how big are they, Richard?
They're about 0.3 to a mil in size, and again, apologies for those that are listening and not seeing me today on the camera, but I'm holding up a sachet, which within the sachet you've got 6,000, there are give or take a few, pupae of the Trichogramma wasp. So this is the product that Dragonfli are selling into the market, and those parasitic wasps will hatch from a pupae. And they're so small that you're not really going to be able to see it. Maybe that Hugh and Alex might see that there's a tiny little hole at the top of the sachet, and the tiny wasps will release themselves out of that once they've hatched out of the pupae. They release themselves out of that hole there into the cupboard or the wardrobe or into the area where the textiles have been held. So if you spot a parasitic wasp, you're doing really, really, really well. We do release them en masse, over a period of time, and you might see them. And I think one of the things that we'll talk about, sort of the strategy of clothes moth control, is that we use these things called sticky traps or delta traps, and I'm just holding one up at the camera now. This is sort of the version that Dragonfli developed for clothes moth itself. And this is a very, very good indicator of where I've been able to tell whether you've got clothes moth in your wardrobe, in your house, in the etc., in the textile collection or museum or stately home. And basically, as a starting point for people who want to think they've got a problem and really want to identify it, they're basically going to put one of these traps up in the area and attach to it a pheromone. Now I will open this sachet on camera because inside what you've got is a little sort of rubber septum, and what that's got impregnated in it is the synthetic version of the female hormone. So what that's going to do is then that's going to attract males onto my little sticky trap here, and then you'll be able to then see you've got the actual pest itself. So it's a really good way of indicating that you've got the pest. Alex, do you have a question?
No, I'm striking my breath.
No, it's all right.
that was me deep in thought. I mean,
So,
I do have one question.
Yeah,
Sorry,
go
before you
for
get
it.
much further in. So you've put your trap up. Now these wasps, they're tiny, as you say, and I imagine wasps that small. You're not really looking at wasps that are going to be flying great and
No.
sort of like heroic distances. They're mostly going to be scuttling and running and things like that. So what kind of sphere of protection are we looking for from one of these packages? What is the roaming distance? How
All right.
close do you have to get it to that nebulae of closed mouth larvae?
So we normally try and put these things as within situ, within say like the wardrobe with the woolen garments in it, or onto a carpet, say, that's infested with clothes moth. So they've got to be quite close because they're not going to fly very far. They're very small, as we alluded to, and again they need to seek out the actual clothes moth's eggs, and this is where it gets a little bit horrific, because what we've got to get these guys to do is come out of the sachet. That's just a convenient way of putting a lot of wasps into a packet, and those wasps will then have to find the eggs of clothes moth to actually then parasitize. So once they parasitize the egg, they will the wasp will lay its egg inside the actual egg of the clothes moth, and a new wasp will be then formed and then hatches, and you get the whole thing perpetuate over a period of time. One of those sachets, just out of interest, will probably cover you an area of about 25 square meters.
That's
quite a big area, particularly in a domestic setting. And again, with that sort of monitoring, which again in a small area, and I think me and Hugh talked about this. We were talking about one of your customers who had an issue in a loft space.
Yeah.
Maybe even just one or two of these traps could trap quite a lot of moths. So it's almost as a passive control mechanism. With the trichogramma wasps as well, could be a very, very effective control method in a small area. So, most of the customers are either domestic users, commercial users, commercial settings where they've got, think people like have got textile collections, museums, that sort of thing, where we don't really want the clothes moth and the larvae, because it's the larvae. It's important to say that the larvae of the clothes moth is the one that's doing the damage to the actual woolen garment or the carpet. We don't want them. So yeah, and again, those sachets will last about 2 to 4 weeks. So the release over a period of time, and really in sort of, because it's a pest. Probably many of the listeners have seen, maybe even seen in houses or in commercial buildings. It's there all the time, because of our love of central heating and woolen carpets and woolly jumpers and everything else. These things have just designed themselves to exist alongside human beings and animals, and build up and perpetuate different, multiple generations of populations over a whole year. It's not like some of my agricultural pests, which sort of maybe have one generation a year. They come and they go. These things are there all the time. So it's, yeah.
That does bring me on to a question. I know Hugh's got a question as well, because we've both been sort of like doing this. But I'll ask mine, you ask yours, and I've got a follow-up. But as you say, because of the advent of central heating and the propensity, because previously, that was my second question. I'll leave that for later. But we have underlay, we have woolen, sort of like we even have insulation on the walls, which is totally natural fibers. As you say, we don't have peaks of emergence anyway. Okay, you have a peak over summer, but you can have that sort of like population existing and actually sort of like bubbling and boiling away all throughout the year. Now, as you say, these parasitic wasps are specifically targeting the egg stage of development, but of course, anything first instar larvae, grub and crawling about, that thing may take, and we know that clothes moths are not particularly fast growing animals, even in the best of conditions, may take several weeks to several months, and then the pupal stage can take a bit longer. So actually there is a window within which you can remove all of the eggs, but then have a recruitment coming over the top. So my question is will there be a point where your wasps will reach a critical mass and keep rolling over? They will keep self-perpetuating their population in order to control, because if that one sachet only lasts for 2 to 4 weeks and the generation time of a clothes moth is 2 to 4 months, then do we have to keep putting sachets down?
Absolutely.
Okay. There we go.
Yeah. And that again is something that we do see in horticulture or in agriculture, particularly in horticulture in glass houses, where we have to put in regular inputs. I mean, the classic example is Incarcia formosa, which is another parasitic wasp which kills whitefly. So we're having to sort of put in a low level of these wasps into a small space, or glass house or cupboard, if you like, for the clothes moth over a length of time until we try and sort of reduce that population. Now, there's other things that people can do, and again, a lot of people out there are probably seeing this in a domestic setting. Things like simple things like hoovering, freezing of garments, anoxia, which is sort of reducing the levels of O2. These things can be killed by those sorts of methods. And again, a lot of the sort of museum people who are in charge of sort of big tapestries and collections do a lot of hoovering of these things, or careful hoovering, and that again can take out quite a lot of these big populations quite easily. But as you say, Alex, you've got to, with the wasps, it's just not one hit. It's just not a one-hit wonder. If you've got a perpetuating population of clothes moth, you've got to go in quite regularly, at regular intervals, into that area until you do see, using your traps as an indicator of being able to see a reduction in the population. And again, temperature is really, really critical. We've said, the wasps are active between 15, 30, 35 degrees. But again, clothes moth can exist in quite low temperatures, even with low levels of food available. So again, it's all about that holistic approach, starting off with some of those basic things like the hoovering, the hygiene side of it, and then moving into sort of the biological control.
Yeah, it's fascinating, isn't it? And as you say, all of these things, I always say, and in fact I said it on Tuesday and on Wednesday, the best way to deal with any pest is to know your foe, and that goes double really when we're talking about biological controls, because you need to know your foe and equally know your co-pilot as well, it would seem.
Absolutely.
So work with the advantages of both.
Yeah, I think that, yeah.
Oh, sorry.
So couple of questions. You said that they slowly release out of the sachet. Why don't they all hatch at the same time and just fly? Do you breed them so that they are at different rates? Do you specifically breed them like that so that they are going out? And how long was that?
So about 2 to 4 weeks. The sachet.
So if we would decide
on temperature as well, obviously if it's warmer, hatching rates tend to increase a little bit. But it's normally, the rule of thumb is normally about 2 to 4 weeks.
So if we were looking at controlling a problem, say it was something like, let's just pick a woolen mill or something like that, we would be looking at doing visits every 4 weeks to come back, check the monitors, and then see if we needed to release any more. Would we see a reduction in the moths that we're actually catching, and then think, well, we've still got 200 on this trap, we need to release XYZ in that area over there, area over there, we've only got 2 on that trap, so perhaps we won't release any more at that time, this time? Or would we just say, we've got moths on that trap, we're going to release them anyway?
Yeah, I think there's, the release of the wasps is about 2,000 per week. So again, you've got 6,000 in the so it's going to be, on average about 3 weeks, 3 to 4 weeks, you'll get that, all the pupae hatch and you get the wasps come out. But again, as you said, Hugh, you've got them, you're going to be able to place those sachets in strategic areas where you're picking up the moth, the moth problems, and hopefully over a period of time you will start to see a reduction in the populations. But again, it's a repeat introductions with monitoring, which will allow, and your due diligence, which will allow you to get on top of the
so you really want to be hot spotting the areas
Correct.
where you think, using your monitor points out at certain areas, and then saying, yeah, it's in this area here, this is where we need to release them.
Yeah, and again, using them preventatively, is a really good starting point, particularly if you've got really high value. So some of the museums, stately homes, they've got extraordinarily valuable tapestry, and pictures and things made out of material that are going to be affected by clothes moths. So it just becomes cost effective for these people to put these things in preventatively, even if they're not seeing clothes moth damage or even clothes moths. And I know that's sometimes a difficult one for people to get their head around, because again, they're spending money on a product that when they don't actually see a problem. But the worst thing you can try and do, yeah, absolutely. The worst thing
paying not to see anything.
Fight a fire. We end up fighting fires otherwise. And with biological control, we know that fighting fires with biological control is really challenging. It's not impossible. It's not impossible, but my little predatory mites or my nematodes or my parasitic wasps or whatever are really going to struggle sometimes to get on top of a big pest problem. So
we actually,
little and often,
we actually do. One of our clients is a bedding manufacturer, and they tuft the tops of their beds with cashmere wool. Wow. And they sell to a very well-known retailer, and they sent some of their beds there, and the retailer suddenly found out that they could see moths emerging in the showroom from these very expensive beds. Wow. And we ended up fumigating, phosphine fumigation, 100 tons of cashmere wool at the time. So yeah, it definitely sounds a viable prospect to let a few wasps go every now and again.
Yeah.
But you said about the temperature. So if, for instance, in the situation where, so basically we've got an eco place, and they've stuffed the loft section between the false ceiling and the roof with wool. And we did have talk about it. So the wasps do actually need room to take off and search around as such, don't they?
They do. And if you can get the sachet to lie flat, remember there's a hole in there, so it's no good putting it upside down and covering the hole, because the wasps won't be able to find their way out. We do know that they tend to sort of jump up vertically. They tend to move vertically. So again, being able to sort of put these out as flat as you can get them onto a surface, the better, because you're just going to give them a better chance of being able to be released out of the actual hole in the sachet.
If it was a house or a museum or a factory or a warehouse, would they be better off up any? Is there any height? Do they just go on the floor or up on the?
I don't think there's any height restrictions. But yeah, I think being able to. I think one thing about putting them on carpets is obviously they're going to be on the floor, and sometimes they're going to get damaged or trodden on or blown away through an open door or whatever. So if you are going to put them on the floor, they've got to be maybe secured down with something. But again, most of these products are going into cupboards, into drawers, being clipped to tapestries, that sort of thing, being put into museums, in sort of warehouses, that sort of thing. So it's being able to there's a hook on the actual, you can see there's a hook. So if you need to hang it up, you can. So again, if you've got a roof space, you could be sort of slipping these down the side or eaten by a dog. Brilliant.
So the other thing, sorry, Alex. So if you've got a warehouse and it's during the winter, you're not going to want to be using the wasps because they're not going to hatch out at below 15 degrees.
Exactly. Yeah. The temperature is, again, with a lot of our biological control agents, we have to be very careful about temperatures. And again, some of these things, you never want to overpromise. And if you don't get the right temperatures in the environment, then again, they're not going to work effectively. So, whether it's a parasitic wasp, a nematode, a big bee insect like a ladybird, they've all got their temperature ranges to move around in and be, and to be effective in. And we know with the trichogramma wasps, they do need that sort of 15 degree temperature.
But that said, we always get a peak of closed moths during the summertime anyway in the places that we monitor. So you would be releasing them more at that time to control the issue then and there anyway. And we're using traps at the same time, yeah, to monitor it. Okay, cool.
As a monitoring method.
Alex.
Two things. Number one, I wanted to sort of like go on a sidetrack and nerdy as to why insects need temperature. But I mean, maybe Richard, you could explain that one a bit better. Otherwise, I will just go full bore on this.
You'll ramble.
Ramble. Bugger off. I wouldn't ramble. I would educate in a passionate and non-stop manner. But I mean, insects are fundamentally different, of course, to mammals. So why is it that temperature is so important to them? And let's let the doctor of entomology tell us this.
Well, I'm happy to talk about that. I mean, look, insects need temperature for various different functions. Basically to function, any living organism needs the right temperature to do that in. And predominantly with insects, it's about breeding and actually perpetuating their population. So again, they're going to need that right temperature to be able to do that and to function correctly. And if that is, they have to go through they have to be a parasite like a wasp. They're going to need that optimum temperature to work at. If you fall outside of that temperature range, it's not to say that they're not going to work properly. I mean, again, go back to the entopathic nematodes. These go back millions of years. They've evolved over millions through ice age. Whether they were active in the ice age, who knows? But we now know that some work at colder temperatures, some work at warmer temperatures. But there tends to be that optimum temperature range where insects and like all living creatures will work at. We all know we've had a really, really hot summer, haven't we? And most of us won't really work very effectively after about I don't know, depends where you're from. Like me from Yorkshire, 20 degrees, I think that's about my limit. But yeah, it's if it gets too hot or it gets too cold, then all the metabolic functions of an organism will tend to stop functioning. It's only the same in insects. But maybe Alex can add some more to that.
Only that we as mammals at Holiotherm, so we take a different survival strategy. We maintain a body temperature that's at the optimum for our enzymes, whereas insects take it a little bit other. They'll have a range of enzymes that may be more effective at different temperatures,
correct,
which is, they have to put more energy into that. But actually, when they put their bodies as poikilotherms into the right environment, their enzyme activation temperatures are significantly more effective, so they don't need as much food. It's why they can hibernate, it's why they can go over winter. It's why they don't need to eat as much. We have a huge calorie requirement as holiotherms, whereas poikilotherms, not nearly so high, not nearly so hard, which is why they can be so prolific on such a small amount of food. That's about what I say. So it's all down to the temperature and this wonderful word poikilotherm, which is just wonderful, isn't it? But there we go. I've got one other question before Hugh jumps in. So how do the wasps find these moths? Because a lot of these moths, before there was carpet, because it wasn't like God looked down on man and said, that's a rather nice cashmere jump. You know what I'm going to do? I'm going to invent an insect specifically to upset your lives right now. Our clothes moths were existing, and they were the cleanup crews of things like birds' nests and cleanup crews of mammal dens and stuff like that, which had fuzz and fluff and fur pulled into them. So when it comes to these wasps finding moths, are they looking for something specifically released by the moth, or are they looking for evidence of these nests? You know, are they looking for the smells of birds or looking for the smells of mammals? What's actually attracting them in at this point?
So they're sensing chemical cues, as a lot of animals, particularly insects, do. The female trichogramma wasps locate the moth eggs by sensing chemicals. Now, again, I'm not the world's leading expert on trichogramma wasps. How they do that is very academic. But again, it again, with a lot of insects, they tend to be picking up environmental signals and then homing in on them, which are obviously being given out by the actual trichogramma. The clothes moth. And it'll be different for other species, but they are very, very sensitive antennae, and obviously be able to pick up these sort of chemical cues quite easily. And again, that's borne out by, a very good example of that is obviously with the clothes moth itself. Being able to pick up the chemicals that are being released by the actual pheromone. This is just basically mimicking the female. And what we're doing there is actually disrupting mating. They're very, very sensitive in so far as picking up the chemicals in the atmosphere.
I have one other, but Hugh, you look as though you are the coiled spring of anticipation here.
No, I was. You go.
It's okay. Well, just on the flip side of that, which was sort of like, what are they looking for? Are there any sort of like big no-nos that we should be avoiding? Is there anything that we might do to the environment that would hamper these wasps' ability to find and locate their prey? I mean, so for example, if we had previously done a heavy insecticidal spray with water and sort of like washed a lot of stuff down or things like that, just for interest sake, is there an order within which we should approach these situations? Is it, if you've used control X first, don't bother going down the biologicals route? Should we always start with biologicals and then escalate up? What are we looking at doing? What does a practical strategy for the control of these look like?
Okay, so that integrated approach, I think we've sort of alluded to some of it as we've gone along, haven't we? So basically, you mentioned, Alex, about knowing what you're trying to control at the end of the day. First and foremost, there's lots of information out there on the internet about clothes moth. We've got two particular species. You've got the webbing clothes moth, which is the classical clothes moth that we tend to see. But you've also got this case-bearing clothes moth as well, and they're very, very, very distinctive. The moths themselves, insofar as coloration, etc., and actually even the larvae, because the case-bearing larvae have a portal case. So what they're doing is, bizarrely, they're dragging this thing around like a little home, mobile home, at the back of the larvae as a way of being able to protect themselves from predators and the environment. So there's those two species. So know your pest, then obviously know the tools that you're going to be using. Certainly, anything that's been treated with insecticide is not going to be great for certainly not going to be great for the clothes moth, but it's certainly not going to be good for the trichogramma wasps either. So again, if I go back to my horticulture or my agricultural settings, I'm always asking my growers, look, before you put beneficial insects into your greenhouse, have you treated any of your plants with an insecticide or an acaricide? Because they will have an impact on the beneficial insects. So again, trying to understand what's already gone on and what's been impregnated, say particularly into a carpet or clothing or whatever, is really, really good to know. The monitoring, absolutely, that'll help you identify what species you've got, and being able to sort of give you an indication of population. And then it's sort of maybe going through some of those basic holistic approaches of trying to sort of get rid of what you've got, trying to reduce that population down as best you can by things like hoovering. And again, I've seen people put even their woolly jumper in the freezer to try and sort of get rid of clothes moths. There's all those sort of those little things that can be done, and then you're going to go for the introduction of the biological control mechanism. So it's a sort of stepwise integrated approach, if you like, and it works really, really well. And I should say, from Dragonfli's point of view, the owners are a gentleman called Julian Ives, and talking to Julian, over the last 2 or 3 years, this product has become extraordinarily popular, to the point it's become almost the most popular product that they sell on the internet. So yeah.
Well, that brings me on to another. So, how species specific are these wasps? Because you think most biological controls, it's a very sort of like narrow scope of parasitic species that they're going to be looking at. But of course, you say 2 species of curlew moth there. We've got Tiniola and Tinia and Tiniola. So we've got the 2 different. They're not just 2 different species. They're 2 completely different genus. And of course, the wasp that wasp will happily parasitize both of those. Will it parasitize other forms of wasp? I mean, I can't think of a reason why you'd want to use parasitic wasp to control, let's say, Plodia or Interpunctelli, not Plodia, but Ephestia. Would it work on things like that? Would it work on species outside of those 2 genres? Okay.
So Trichogramma evanescens, which is the species that we're allowed to use, if you like, in the UK, does affect a lot of other larvae and caterpillars out there, and eggs of insects. So, things like corn borer, European corn borer, we know that trichogrammas affect that. That's a big problem if you're growing maize or sweet corn. Tomato moths and numerous other pests can be controlled with trichogramma. So, Alex, then they're not very specific. There are specific relationships with certain wasps and certain insects, but with the trichogrammas, they tend to be quite, generalistic, if you like. I've been looking at some projects of using wasps on European corn borer outdoors, to try and, because again they don't have the insecticides that they used to have to control European corn borer, which is a resident that comes over from the continent every summer, albeit we do get a bit of an overwintered population in the UK. So yeah, they're quite indiscriminate insofar as being able to parasitize other insects.
It's interesting, and it just again goes to prove how our professional sector really is the poor cousin to agriculture, isn't it? Because these were not designed for close moths at all, were they? They were designed for greenhouse and agricultural sort of like management. One of the other
biggies that's come along in the last few years has been, if anybody out there has got a box hedge, you'll have seen it being affected by 2 things. One is a disease, Phytophthora, and the other one, the big one, is box tree moth. And again, using trichogramma is a very, very effective way of being able to try and reduce those populations outdoors. So
that is interesting. I mean, so let me just pick up on that, because classically box moth are really, they fall under our purview, weirdly enough, because they're not on agricultural land, and they're mostly sort of like, when they become pests, they're pests in urban areas. So you've got the box hedging all through London and places like that. And
I've
because
got my lovely little conifer, my little pyramided box tree, and my little balls that I trim the balls every month in the summer.
Well, yeah, why does it not surprise me that you are proud of your trimmed balls in the summer, Hugh? I mean,
but they get a hole quick, don't they? And they chomp the side out. They really do, on little basket cases.
But because they make this tenting box, they're very impervious to almost all insecticides. In fact, the insecticides that should be able to penetrate through that silk will also very wildly and rapidly defoliate the plant at the same time. So we've been left with very few options available to us as professionals in order to treat these, other than cut and burn the things, because they've got these irritant hairs in them. But if you're saying that, you can...
Bicam W works quite well on them.
Well, it did. It doesn't anymore. It's gone. But with that, you're saying that you find some sort of like some box that you just pin one of these to the side of the tree. I mean, my next question is, if it works on box moth, which is an issue.
Wow.
The next two issues that we are facing, challenging the UK's professional and horticultural sectors, is of course the advent of both pine and oak processionary moth, which do similar things. So would this be a tool available to us as pest managers to aid in both box moth and oak and pine processionary moth?
Well, I think, yeah, you've really struck a chord there. Now, so I wouldn't, for those two pests, oak processionary moth, particularly, which is something we've worked on for a good number of years now. I certainly don't know if the trichogramma wasp would affect it. I think it might struggle. But the one thing that does affect oak processionary moth is entomopathic nematodes. So again, using these sachets alongside the entomopathic nematodes, which will infect the caterpillar. So these are affecting the eggs. The wasp are affecting the eggs, and obviously the caterpillars are being killed by, say, entomopathic nematodes. It's a very, very clever way of being able to sort of reduce a population. And OPM, as you rightly say, Alex, is becoming a bigger issue, particularly in the London area and the southeast of England, where there's lots of lovely oak trees. It's a public health issue. It's not necessarily a pest that's destroying oak trees per se, albeit young saplings can get defoliated quite quickly. But the bigger mature trees that have the big nests, the OPM nests on them, tend to be an issue in parks and gardens and schools and areas, and it becomes a public health issue because the hairs on the caterpillar and the hairs on the nests are an irritant. And if you've ever seen some pictures of people that have been affected by it, it's a really, really nasty thing. Again, worker safety, people who are managing trees, which probably you know about, these people will have to wear quite a lot of protective clothing if they're going to doing tree work, to try and stop them getting contaminated by nests. So again, using more holistic biological approaches is becoming more and more of a popular tool, if you like. And again, that's front and center of what we're trying to do at the moment. But again, we're going back to the box tree moth. It's a sort of culmination of two things. Again, it's the sachets and it's the nematodes. There is some mating disruption out there, I think, from I believe Syngenta, I think it's their product.
Dismates one, isn't it?
Right. Yeah, there's some mating disruption out there, I think, for box tree moth as well. But
I was thinking of dismate for closed moths actually, and also SPI. So if we're going into, going back to our closed moth issue, we're going back in, we're talking to Mr. Miggins, the site manager or curator, anything like that. They've got a humping closed moth problem. Probably not so much with the domestic people, because they may be more likely to buy them on the internet themselves. But if we had a humping problem somewhere, how long? I mean, there's no promises because it's a natural thing. So how long would we be thinking that we should get some sort of control on the issue? Or is that just like how long's a piece of string?
I think so. I think I love being put on the spot, but yeah, I think it's quite a difficult, a challenging question to answer, effectively. But I think in a number of months you'd be able to see a relative reduction in population. But again, it's always going to be dependent on where you're working, what sort of the environment is, the temperatures you're working at, etc., and the starting population. So yeah, quite a difficult question to answer.
It sounds like the traps here, they're not just part of the IPM, they're part of the sales pitch. Because as you say, you are breaking the life cycle, but you're not necessarily, but that cycle needs to run back to the beginning point where it's being broken. So you can, on day one, release your wasps and kill every single egg in the environment. But your homeowner is still going to see potentially larvae, potentially moths cropping up, because you're not stopping those larvae turning to moths. You're stopping those moths creating more eggs and that cycle going around. So fundamentally, those traps are there to let you know where you're putting, but you need to have a good hard conversation with your client to say you are going to be capturing moths every day, but the idea is you'll catch 10 in the first week and 7 in the second week, and I'm facetiously bringing these numbers up, but the idea is you're catching less as fewer and fewer are recruited back into the environment. That number will decrease and decrease, and then even when we get to 0, we need to give it a couple of weeks, because we need to wait for those last couple that are in their pupal forms to bust out, because if we miss them, then the whole process is going to start again on fresh ground. So there is a big Hugh, what was the thing you always said about pest management and showmanship? What was your expression?
Service is a show, so put one on.
Yeah, so it's a show. So you need to sort of you need to go through that whole process and explain and bring your client in. Otherwise, if they just expect you to throw down the lavender scented sachet into their drawer and never come back again, it's not going to work in the way you want to do. So yeah.
Going off on a tangent, just for a lighter side, we do a pepper grower. They were growing peppers, and they were releasing some insect that was in sachets of wheat germ. But we developed a massive problem with rats, because the rats were coming in and climbing the plants to get the sachets of wheat germ, and it was costing them a fortune in new packs of insects.
Yeah, unfortunately, the sachets that we use, I think the ones that you're talking about, I don't know the particular sachet, but again, I don't know which different types of carrier material that we put things like predatory mites within a sachet, or in this case, we've got wasps in there. Things like rodents will be attracted to them, and one of the things we've not been able to make these sachets is rodent proof or mouse or rat proof. So again, you're the experts, you guys, on rodent activity. They will get anywhere and everywhere, and quite easily. And if they smell something nice and tasty, they'll nibble. We even have a sachet that's made out of a foil, which is a compostable foil. Which we use a lot of in greenhouses, and again, you do see evidence of mouse activity. They go up the stanchions and they nibble the sachets. So yeah,
I'm assuming that the reason you use wheat is because it's a good growth medium for things like clover mite and for flower mite.
There's lots of different carrier materials we use. For our lacewing larvae, we use buckwheat. So it's a big, they're big husks, and they keep the insects away from each other in the tub. So, but we use bran, and we use all sorts of sawdust and various other carrier materials.
That's what it was, bran. Yeah, you pull back the Mypex, and you'd see a great stash of bran sachets, and think,
yeah. But then you've got to go back to you guys and sort of start to talk about the rodent control first.
Oh yeah.
No. It's super easy. The answer to this is you start using, instead of just plain unadulterated whole wheat, you just use some difenicum cut grain in there. 2 problems, 1 solving with that. Take it away, eat it, die. Job done. It's a dual control. There you go. Registration might be a bit more difficult on that, but.
Rupert said that, which is true to a certain extent, isn't it? The homeowner, generally speaking, has got used to next day delivery, and those 2 things we're talking about, they want results really quickly. But again, it's all horses for courses, isn't it? If you've got, a client that is particularly doesn't want any insecticides used at all, and when you look at the issue, we've got another one that we're looking at, and hopefully we're going to have a trial with them with the wasps. But the place is absolutely stacked full of stuff, to actually prep it and get it ready for a closed moth spray insecticidal treatment is just ain't going to happen. And some of the Afghan rugs and things like that, I ain't spraying that with any water-based insecticide. It's not going to happen.
Yeah.
They're worth thousands. Well, might run like the blood off the walls with the bed bugs. So
where's your sense of adventure? You know, I can literally hear your insurance company at the moment quivering in terror.
We did have one stately home where we quoted for it, and at the time my public liability wasn't enough. They wanted 10 million, and we quoted against a rather large company. And I said to the guy, you know, we haven't got 10 million pounds worth of public liability, and he's like, I tell you what, he said, we'll pay for your public liability. We are saving so much money coming for you. They paid for our public liability uptake. And we had that for quite a few years.
Do you know what that story tells me more than anything else?
We were too cheap at the time.
You were too cheap.
Yeah, but this company was actually talking about taking all the rugs out of this place and building a fumigation bubble on the front lawn, you know, and I was like, no, you don't need that. You don't need that.
So man, anyway, I do it with a hand sprayer and a can-do attitude. You just
we did.
We did. Right. So we're coming up to the last hour. We're coming up to the last 10 minutes. And so what we like to do in the last 10 minutes is turn this table on its head a little bit. So, Richard, is there anything, you know, that you would like to ask Q and I, ostensibly as members of the pest management community? Is there any questions from your side? Anything that you would have wanted to know, or sort of like anything you need, you know, just a question for us to turn the tables on its head a little bit?
Well,
that's put you on the spot, isn't it?
That's, hasn't it? I'm just wondering. I used to subscribe to Pest Control magazine, and obviously I used to see, you know, obviously quite interested in sort of pest control in general as well. I did a little bit of that way back at university. I think I wrote an essay on controlling grey squirrels at one point. I think at some point. Yeah, I'm just wondering what sort of between both of you, you know, what levels inquiries have been coming through and on things like clothes moth. Is it becoming a bigger problem, you think, or obviously because we could see it from a sort of a hope, you know, for a sort of a from domestic side, because the customers that are buying the product, but from a commercial side, do you see that there's going to be a bigger move to going more biological with these trying to control clothes moth? What sort of level of
you take this because you're a bit more.
Yeah, I think getting, I mean, obviously, because it is quite new, and back along I was, you know, interested in it, and I approached a few people for advice, and or from other companies, and they were like, well, we don't really do that sort of thing. So that was one of the reasons I sort of, you know, asked if you'd come on, because it is quite hard to get. It's quite a novel thing, really. And you see articles about, you know, the British Museum has used parasitic wasps, and you're like, oh yeah, I'm interested in that, and try to find out any information, and you can't really find out who did it or whatever. So I think now certainly from listening to what I've heard, now we're a little bit more forearmed is forewarned. When we're working, you know, when we're walking into places, it's an option that we can definitely use. And I think, you know, just like going back to my thing about the warehouse full of wool and stuff like that. Well, it's certainly going to be cheaper us releasing clothes moths, parasitic wasps every month than it is, you know, fumigating 100 tons of cashmere wool.
Absolutely. So, showing there's a return on investment there. And again, some of the studies that were done, you know, you can go and look at these on the internet, and I think we could probably share some of this with you guys after today. You know, there's been work in the UK and in Europe on this, you know, and field studies to show the efficacy and the levels of reduction in moths. That I believe there was a study at Burley House in Stamford. And again, going abroad, you know, I think I'm just looking at some of the notes here. There was a big study done in Germany at one of the transport museums in Munich, believe it or not. So I think it's all credit, really, and credit's due really is down to Julian Ives, who's the owner of Dragonfli, and his sort of passion for this subject and being able to sort of get this product to a commercial level to be able to then be able to sell it, because again, a number of years back it was just not available, and I think now with that demise of insecticides, and particularly the use of insecticides in domestic settings, and certainly places like museums and things where the public are around, anything that's more biological, holistic, is really only a good thing. And again, one of the other areas that we work very, very extensively in is things like botanic gardens. So again, where the general public are every day walking around, looking at the beautiful plants, etc. These places can ill afford to be throwing lots of chemicals around, particularly when the general public are there, or even in the evenings, because it's just not cost effective to do so. So the biologicals, we haven't really mentioned, they're working 24/7. If the temperatures and the light levels are there, they'll be quite happily just ticking over, depending on what species you're thinking about.
So we've been speaking a lot about our clothes moths and the rest of it, but just to wrap this up, there is a couple of species of parasitic wasps who specialize in parasitizing things like cockroaches, and this is cockroaches all the way from your Germans all the way up to your Americans, great big things, and they're called jeweled cuckoo wasps. And if you guys want to see possibly the most beautiful insect on the planet, barring none, Google jeweled cuckoo wasps, and they exist in the UK. And when I was a consultant there was a plan, there was a zoo that was having huge problems with Australian cockroaches, and there was this tepid thought of trying to find some of these, because they exist and fly around in the UK, and natural predators, parasites. But imagine that, can you imagine opening the back of your van and letting out 10,000 sapphire wasps into someone's... I don't think anyone would mind. You'd encourage cockroaches just to keep these things around, because they are beautiful. So yeah, when are you getting some cuckoo wasps in, Richard? Like when are you breaking into those?
We do get that question asked a lot, not necessarily about cuckoo wasps, but about the most... we've seen this predator on the internet. When are you going to be able to produce it en masse to be able to release it? And I think there's that cockroach wasp thing, that relationship is pretty nasty and gruesome.
Great.
From what I've read and I've seen on various of the years, it's quite a nasty...
Sounds fantastic.
Yeah. Right, so let me tell you, because actually the reason I know so much about these is a gentleman I know called Graham, who, if anyone's ever watched The Wild Thornberrys, he's like the spitting image of Nigel from The Wild Thornberrys. But he also breeds and does a lot of the filming for some of the fairly big, natural history documentary type groups around the world. And one of the things that he filmed recently was these cuckoo wasps. I say recently, a year or two ago, and they were absolutely phenomenally beautiful. But as part of that, he had to do his research. So he's a scientist, he did his research. These cuckoo wasps, they'll lay their eggs in, so that they'll sting twice. They'll sting once to paralyze, and then they'll sting again with the ovipositor to deposit the eggs. But cockroach is big, and these wasps are relatively big as well. So what they do is these larvae break out, and they'll swim through the hemolymph of that insect, munching away the hemolymph, but they won't eat anything that will kill that cockroach. So they start off by eating the fatty tissues, and then they'll move on and they'll eat the gonads, the reproductive organs.
That's right. Yeah,
and then they'll move along.
There's a particular order to keep it alive.
To keep it alive. Yeah. So they'll eat the meat out of the legs. And then when they finish doing that, they'll start to work on the the intestines, the hindgut, the foregut. And when they've done that, they finally then break down all of the rest of the materials in it and spring out of it like a xenomorph. It is disgusting and fantastic.
Can you imagine Sean? I'm glad Sean wasn't doing it, because he hates insects
with a passion. Why? How can you hate that? how can you hate an evolutionary process that has led to some barbaric levels of Geiger sort of like H.R. Geiger's sort of like beautiful pictures, and our xenomorph and our alien. It was the inspiration for both, I believe, was our parasitic wasp. But there we go.
We better ask our last 3 questions as we're coming up to the hour and a half.
Is that your polite way of telling me not to stop getting so excited about terrifying insects?
No, I was quite enamored actually. Richard, we've got this joke because I always I normally sit in the background and I send messages going time, it's an hour and a half, time, cut it off now, cut it. So I can't, I got to. So we always ask 3 questions at the end of each podcast. And they're always the same 3 questions. So the first one is, shall I do that? Yeah. Have you enjoyed your time on the podcast?
Absolutely, been an absolute pleasure.
Thank you. Nobody's ever said, no, you're a bunch of twits, which is good.
No, Robert Moon did. Robert Moon did.
I can't remember that one. So
lovely stuff. That's how good. So I'll ask you, give us a shameless plug. So if you could get all the pest controllers in the UK tomorrow to wake up and do one thing on your behest, what would it be?
That's a really good question. I think go to the Dragonfli website, really. Go and look up, educate a little bit more about biological control. The Cobalt website, the Dragonfli website are very, very good starting points.
We'll put some links up on the Facebook page.
Excellent. Thank you.
So that people can know where to go for that. And the last question we always ask is there anybody that you can think of that you would like to see come on our podcast? That puts everybody on the spot every week, so don't feel ashamed.
Doesn't have to be our industry, but something that you think, someone that you think a pest controller or someone in our industry would get value from listening to.
That's a really good question. I can see, Alex, you love entomology, and I think if you get anybody from the Natural History Museum to come and talk about insects in any shape or form, there's a lady, and you're just going to have to excuse me because I'm going to have to remind myself of the lady's name. She is.
While you have a look for that, if you managed to get someone from the Natural History Museum on this show, I would probably turn inside out and burst into tears.
If you could get a lady called Erica McAllister to come on the show, that would be amazing. She's the fly lady at the Natural History Museum, and she deals with all sorts. Well, she deals with flies per se, and I think flies
I can try.
These people are very approachable. She's very, very good at presenting and sort of talking in sort of things like this. She's been on radio a lot, TV, and she will.
I'll try. I don't mind trying. I tried quite a few people, and I'm used to getting ignored now.
Yeah. So sorry, I was put on the spot there, but I think Erica McAllister. She's the fly lady at the Natural History Museum. So yeah.
It's a challenge, but it's not as much of a challenge as Elon Musk was that somebody said. Well, like, yeah, right. Yeah, okay. Yeah.
Wow.
Yeah, I think
so when's he coming on?
Sometime 2020 never. We can keep trying. Richard, it's been such a pleasure to have you on tonight. It's been fantastic, and thank you for putting up with my exuberance around insects. Ostensibly, I'm the rodent guy in my company, but can't take the insects away from me. Absolutely love them.
And on that note, thanks ever so much again. And if you just hang around in a sec, we'll have a chat after the titles have rolled. Good night, everybody. Take care,
week, everyone. Bye.
Thank you for listening to the Beauties and Beasties podcast.